My name is Gauvin. I'm an occupational hygienist with the Occupational Health Clinics for Ontario Workers. And today we're going to talk about implications of indoor environment quality in an office environment. So just a quick summary, we're going to start with a little bit of ergonomics, and then we'll go into what is indoor environment quality, what the major components affecting indoor environment quality are, and then there's a new rating scheme called the TAIL criteria. We'll talk about that a bit and then discuss the parameters included in that criteria and then tips to control them. So what is ergonomics? Well, it's the science of studying people at work and then designing the workplace to fit the worker. So ergonomics is not only for making the work better, but also for making it more comfortable and efficient. So in ergonomics, we think of these risk factors, force, awkward posture, repetition or inadequate recovery, vibration. There's also psychosocial. But we'll just go through a quick scenario. So you're a manager or the Joint Health and Safety Committee rep in an office setting. A worker might come to you with complaints of back, shoulder, and neck pain or fatigue and headaches. What's the first thing that we do? Well, we think, let's look at the worker's workstation. Let's have an ergonomist provide an office ergonomics assessment, the recommendations on how to improve their workstation, and give this worker what they need to prevent musculoskeletal disorder, make sure the worker is comfortable at work. So you get them a new chair, a new height adjustable desk or keyboard tray, a new monitor, and you've adjusted everything to the workstation or to fit the worker properly. So you've done all this and still the worker is complaining about headaches, neck and shoulder pains. Well, this is when you need to start thinking, is there a bigger problem here? And maybe there is. So good indoor environment quality doesn't only take into account the ergonomics of a workstation, but all the parameters in a building that affect a healthy and comfortable workplace. So what is indoor environment quality? Well, indoor environment quality refers to indoor conditions in a building related to the health of those who occupy it. So workers sometimes express concern about symptoms or illness caused by exposure from the building they work in. And then complaints are often made when their symptoms get better when they're not in the building. Since humans adapt themselves easily to the conditioned perception of our surrounding conditions in terms of temperature, noise, air quality, lighting levels, we don't realize the gradual adverse impact the conditions can have on us. So in a given era where comfort fuels productivity and health, it becomes important to understand the role of these parameters, and they're often termed as indoor environment quality parameters as a single group on the occupant's overall well-being. There are four major factors to indoor environment quality, and this includes thermal environment, acoustic environment, indoor air quality, and lighting. The other factors that can affect indoor environment quality in a building is ergonomics of the workplace, water quality, and vibration in the building. So the goal is to have a good indoor environment quality to ensure the health and comfort of all workers. So today we're going to concentrate on the four major factors. So we have thermal environment. So this is about being able to feel comfortable with the temperature, humidity, and air movement that surrounds us. It also depends on the type of clothing a person's wearing, what type of activities a person is doing, the age and the gender of the person. And thermal comfort is basically like a state of mind that expresses satisfaction with the surrounding thermal environment. But while working from home, we primarily use fans and air conditioners to achieve thermally comfortable environment. On one hand, while fans may enhance comfort by providing air circulation, they might not help to balance humidity or temperature. But on the other hand, the air conditioner might help and achieve desired temperature and humidity, but they might also lead to thermal shock. So when there's a sudden change in temperature while moving between a warmer zone, like a kitchen or bathroom, to a colder zone. So finding the right balance between all these parameters is important. If an occupant is working in a warm or cold conditions for a prolonged period, it can result in reduced cognitive ability and therefore reduced productivity. So researchers also proved that thermal discomfort causes restlessness, affects sleep quality, and reduces work performance. Elevated temperatures can also reduce air quality as perceived by the occupants in a building, and temperatures can also affect the chemical processes occurring in buildings, such as the air and surface reactions that affect exposures and physical processes affecting emissions from new construction or renovations and furnishing materials. So for acoustic environment or noise, our outdoor spaces are mostly crowded, noisy, and streets are often filled with activities year round. So this really prompts us to find a peace in the spaces that are relatively quiet. So at home or at the office. Um, since we're using, or since we're used to spending more time at the office or at home when you're working from home, and getting engaged in the activities which require us to focus, it's important to remember that noise is not only in the outdoor spaces. A person can get distracted from indoor noise sources like office equipment, so printers, computer server areas, or other loud equipment, making it difficult to focus on activities like working or studying or making phone calls with colleagues and clients. The privacy of speech also becomes important, especially if you work in a cubicle type office space, or if you're working from home and there are multiple family members working from home, or if you have kids running around at home. So it's not just noise and privacy, but also overall acoustic quality. So this would include the echoes, speech clarity, sound frequency, as examples. So when overall acoustic quality is good, we get a sense of quietness, calmness, and comfort. This allows us to focus for a longer period. And being exposed to noisy conditions for prolonged periods can lead to mental fatigue, sleep disorders, and the inability to focus. So this is why it becomes important to give attention to the largely neglected acoustic aspects of offices and homes. So indoor air quality. So air in our indoor and outdoor environment is just a mixture of gases. So it's predominantly nitrogen and oxygen, along with other components like CO2, water vapor, and very small amounts of other gases. However, it's really important, or it also contains many other contaminants in the form of particulate matter, volatile organic compounds like formaldehyde, toluene, benzene, and many others, which are emitted from office furniture, carpets, perfumes, as examples. And if you're outdoors, from vehicles and factories or through natural events. Um, Other types of contaminants are microbes, so you'll have fungal, viral, or bacterial microbes. And while most of them are not harmful to us and are required to maintain our immunity, some of them can be very harmful. So these air contaminants can lead to acute and chronic respiratory issues, depending on the occupant's underlying health conditions, daily activities, and severity of the exposure. So it becomes critical for the breathable air to have a balanced composition by maintaining air pollution within permissible limits as defined by provincial and international standards. For a lighting environment, so in technical terms, visual comfort is a subjective reaction to the quantity and quality of light within any given space at any given time. So as the human eye is always adjusting to the surrounding light levels, a drastic variation in terms of brightness or contrast can result in eye stress and fatigue, and the impact can depend on the following factors. So the type of light, whether it's dim or bright, the time of exposure, the age of a person. So older age people are often more sensitive towards the lighting levels. So good lighting should consider the following. So you should have sufficient lighting for the task. Is there any unwanted dark spots or shadows? Is there any excessive glares? Is there enough contrast between the task and the background? So the new rating scheme for indoor environment quality is called the TAIL criteria. This was developed to have an objective measurement system of building health before and after major building renovations or for new construction. So with the new energy efficient or green buildings, they call them, the addition of new insulation, tighter windows, and new heating and ventilation systems can have a major change on many parameters of indoor environment quality. So we can use this criteria and alter it based on provincial occupational health and safety standards and guidelines, as well as other or recommended guidelines such as NIOSH or ASHRAE to ensure optimal environment quality and health for workers. So if you look at the rating scheme, we have it's based on 12 measurable parameters. So we have temperature for heating and cooling, noise, CO2, outdoor air supply, relative humidity, visible mold, benzene and formaldehyde or VOCs, PM 2.5, radon, and lighting. So the tail rating scheme has 4 colors representing the quality levels of each indoor environment quality component and the overall indoor environment quality level. Each of the tail components can have any of the 4 quality levels represented by 4 colors. So green for good, yellow for acceptable, orange for caution, where you should think about implementing control, and red for unacceptable and needs control, or is basically your limit where it needs control. So the occupational hygiene team at OHCOW went through the tail criteria and compared them to the regulations and standard that we currently use and found that they're generally very close, and either method can be used to provide a good indoor environment quality. So what's nice about the tail criteria is that they have all the recommended levels in one table. But as you can see in the table, we went ahead and added the other common standards to the table as a comparison. So for thermal environment, most standards agree that for thermal comfort, a mechanically ventilated building should have a constant temperature between 21 and 23 degrees Celsius for heating and 23.5 to 25.5 degrees Celsius for cooling. Elevated air temperatures can cause thermal discomfort and exacerbate the acute non-clinical health symptoms known as sick building syndromes. Elevated temperatures can also reduce air quality as perceived by building occupants, and studies show that too high or too low temperatures can reduce work performance and affect sleep. And as mentioned before, temperatures can also affect the chemical processes occurring in the buildings, such as the air and surface reactions that affect exposure, and physical processes affecting emissions of new construction and furnishing materials. So how do we control for this? So ideally, we would like to see a central HVAC system that is well balanced to provide adequate heating and cooling to all areas of the building. However, this is not always the case. So many older buildings may not have an adequate HVAC system, and some don't even have forced air systems, making thermal environment harder to control. So in this case, space heaters or localized air conditioners should be used to try to control the thermal environment. However, this should only be used in the short term, and installing a proper HVAC system throughout the building should be discussed with your employer and your landlord. So for the acoustic environment, occupationally, we try to keep the sound levels below 85 decibels to reduce the risk of occupational hearing loss. However, in offices, we try to keep that noise or sound levels even lower, and this is to limit distractions. People normally get distracted by sound when the level reaches around 55 decibels, and this level has been shown to have a negative effect on performance. So keeping the sound low in a building is not only important for work performance, but depending on the type of building, like hotels, for example, it's also important for sleep quality. In an office building, good sound quality means keeping the noise below 30 to 35 decibels for small offices and below 35 to 45 decibels for open space offices where there's cubicles. So as you can see from the table, there are slight differences from the tail criteria to the ASHRAE standards. However, both are acceptable. So even at low levels, sound can be distracting. So depending on the surface, sound can be reflected, absorbed, or diffused. Therefore, selecting sound absorbing materials for your office will help lower the sound levels and limit the distractions from noise. So the use of materials like carpets, curtains, and foam, these are all sound absorbing materials, and they help improve the quality of the sound and reduce noise in an office building. So many buildings are going carpetless for sanitary reason. If this is a case in your building, having sound absorbing materials on the walls and ceilings, they become more important. So having ceiling tiles, wall hangings like canvas pictures, blankets, or curtains, and acoustic panels can really help in reducing noise levels and providing better sound quality. So for indoor air quality, there are many parameters to include when trying to have a good indoor air quality. So the TAIL criteria lists 8 parameters. This includes CO2, outdoor air supply, relative humidity, visible mold, benzene and formaldehyde, PM 2.5, and radon. So let's take a closer look here. So CO2 is a good indicator of seeing whether you have good ventilation. Generally, a CO2 level of less than 600 parts per million is considered optimal. The TAIL criteria states that a level less than or equal to 500 parts per million above the background is good. So our occupational hygiene team thought it might be a misprint. As when we compare that to other standards, this level is quite a bit higher than the ones that we've been using. So we're suggesting to use the Ministry of Labor guidelines for CO2, which is less than 270 parts per million above the background levels. Now, what are the background levels? Well, these are the CO2 levels that you would typically find outdoors. So these can differ depending on the surrounding environment. In 2022, generally we're finding the atmospheric levels of CO2 around 420 parts per million. Whereas in 1983, they were around 330 parts per million. So they are increasing over time. So with CO2 levels above 1,000, you might have complaints of drowsiness, poor air, levels above 5,000 ppm are associated with headaches, sleepiness, stagnant, stale, stuffy air. You might also have poor concentration, loss of attention, and increased heart rate at these levels. So let's get into outdoor air supply now. So the outdoor air supply is the amount of fresh air coming into space. So ideally, we'd like to see a minimum of about 6 air changes per hour, especially when trying to control for infection. But during the pandemic, this has been the goal for us, is to try to prevent further, COVID-19 outbreaks. And the TAIL criteria recommends 10 liters per second per person, plus an additional 2 liters per square meters of space, which is equivalent to about 4 air changes per hour. This is acceptable for comfort. However, as we're still trying to prevent for further COVID-19 infections, we recommend using the non-infectious air delivery rates, so the NADR, of greater than 6 air changes per hour. This also corresponds to CO2. So in general, if you have 6 air changes per hour of fresh air coming into the building, your CO2 levels will likely be below 700 parts per million. If you cannot reach your 6 air changes per hour, you can always use portable air cleaners to help you reach your target. But remember to look at the specifications of the air cleaners, as they're typically used for smaller spaces. So for larger spaces, you may need to use more than 1 unit to meet your target. So one question that I often get is, how do you find the amount of air changes per hour? Well, what do you need to do to find the amount of air changes per hour? Is first you need to find the amount of cubic feet per minute of fresh air that your system is bringing into the space, then multiply that by 60, and then divide that total with the total cubic feet of the room. And this will give you the total air changes per hour for that space. So relative humidity is an important indicator of comfort as well. So low humidity can cause dry eyes, dry throat, bloody noses, and other health problems, while high humidity can encourage mold and mildew and damage furniture, wallpaper, paintworks, and floors, as well as cause other health problems. So ideally, the relative humidity should be between 40 and 60%. And this can be more difficult in the winter months, as cold air is normally drier air. In this case, if you have dry air, a humidifier can be used to increase the humidity in the air. And if you're having problems with high humidity, which is common in basements. So if you have an office in a basement area or the basement of the building, it could be a little bit more humid. So a dehumidifier can be used to remove excess moisture in the air. So let's go through the rest of the list here. So Other parameters of indoor air quality include visible mold. Anytime you see visible mold, wet, damp, or stained building materials, the goal should be to clean or remove the contaminated materials and try to find the source. There may be water pipes leaking, or sometimes can be condensation from improper insulation or vapor barriers, or leaks from the roof. So investigating the cause and fixing the issue should be made a priority. Volatile organic compounds, or VOCs, are often present in new offices or new buildings and anywhere new building materials are installed. It's a new smell you get when you enter a new home or freshly painted room, or that new car smell. So common health problems for this include asthma, skin irritations, headaches, nausea, confusion, and eye irritations. And if you're noticing higher levels of VOCs, ventilation rates and fresh air intake should be increased. If you have a constant flow of fresh air coming in, it would help clear off gassing from these materials. So Health Canada recommends a limit of 0.3 milligrams per cubic meter, or 90 parts per billion for all VOCs. While the tail criteria is more specific to benzene and formaldehyde, typically you wouldn't really measure for these individually unless you know there's a presence of benzene that might be suspected. So if there's like a fuel spill or a chemical lab in the building, then you would test for these. So PM 2.5, so they call this one the silent killer. So PM 2.5, they're ultrafine particles that are smaller than 2.5 microns, or 2.5 micrometers in diameter. To put this into perspective, a human hair is 50 to 70 micrometers in diameter, making it 30 times larger than the largest fine particle of 2.5 micrometers. So PM 2.5 are virtually invisible particles unless they're present in high concentrations. So in higher concentrations, you'll see a haze or fog in the air. And these particles can be solid or liquid and be made up of many different particles, such as combustion particles from vehicles or heat sources, such as smoke from a fire, for example. Metal particles from smelting, welding, or grinding metals. And they can also be made up of organic compounds and chemicals, such as sulfur dioxide and nitrogen oxides, which are air pollutants emitted from power plants, industries, and automobiles. The respirable particles are particles that can reach the deeper levels of the lungs. So these are any particles that are less than 4 micrometers. So PM 2.5 are particles that are so small that they can go through the lungs and into the blood and can even travel past the blood-brain barrier. They can cause all types of health issues, including cardiovascular and respiratory issues, as well as several cancers. So the tail criteria and the Canadian ambient air quality standards, they recommend an indoor concentration of less than 10 micrograms per cubic meter as a measure of good indoor air quality for PM 2.5. So in comparison, occupational exposure limits for industrial processes for respirable particles that are not specified in Ontario is 3 milligrams per cubic meter, which is 3,000 times more than the tail criteria. So many substances have their own occupational exposure limits, such as metals, silica, and nitrous oxides, for example. And if there are any processes in your buildings that might produce ultrafine particles, it's important to have a sampling strategy for these hazards to ensure they are below the occupational exposure limits. It's also a good practice to sample office areas as well, especially if you have labs or processes in the area, just to ensure these particles are contained in the processing area. So carbon monoxide. So this is a colorless, odorless, tasteless gas produced by burning gasoline, wood, propane, charcoal, or other fuels. It's not part of the tail criteria. However, our occupational hygiene team thought it was important to monitor carbon monoxide for total indoor environment quality. So here's a chart to show the effects of different concentration levels of carbon monoxide. Ideally, we don't want any carbon monoxide in our workplace. However, if your office building has a parking garage, CO from combustion exhaust can make its way into the building. So less than 2 parts per million is acceptable. And the World Health Organization suggests a maximum level of 9 parts per million as a safe level over an 8-hour period. Anything more than 9 parts per million, it becomes important to find the source of the carbon monoxide, and controls should be in place to reduce the amount of carbon monoxide in the air. So the last parameter for indoor air quality is radon. Radon is typically found in the ground, and therefore you should only measure for radon if your office is in a basement. We don't typically measure for this otherwise. And we found that the levels of the tail criteria were a good measure to follow. So control measures for IAQ. So you have CO2, mold spores, VOCs, PM 2.5, carbon monoxide, and radon. They can all be controlled with proper ventilation. Most buildings have mechanical HVAC systems. Proper maintenance of the system is important in helping to keep these air pollutants out of the building. And you can also increase the fan speeds and the amount of fresh air coming into the building to help clear any contaminants in the air. Regular filter changes are also important. So to capture PM 2.5 particles, a filter with a MERV rating of 11 or higher should be used. And for infection control, a HEPA filter or a MERV 13 or higher filter should be used. So research suggests that COVID virus particles measure around 0.1 micrometers in size, but they travel through the air by attaching themselves to respiratory droplets that are 1 micrometer in size or larger. Therefore, a filter with a MERV rating of at least 13 would be efficient in capturing the COVID-19 virus particle. And it could help in the reduction in the spread of COVID-19 indoors as well. So most HVAC systems in buildings are standard systems which come with MERV 8 filtration. Higher MERV filters can be installed in these systems. However, the HVAC company won't recommend it. This isn't because the system can't handle it. Higher MERV filters cost more, and they're often needed to be replaced more often, as they're catching a lot more particles than the lower MERV filters. Also, ensuring a proper seal for higher MERV filters is important to ensure you're capturing the intended particles and that they're not traveling around the filter through leaks. Portable air cleaners can also help in reducing air pollutants and improving indoor quality. And finally, ensuring all gas appliances are sealed and exhausted properly to eliminate or reduce any carbon monoxide that can be released in the building. The lighting. So appropriate lighting can reduce eye fatigue, headaches, and prevent workplace accidents. It's important for health and well-being and productivity of employees. And inadequate lighting causes people to adopt poor and awkward postures. So lighting quality is important for many different tasks. Some tasks require more light, while other tasks require less light. The tail criteria suggests that for comfort in office buildings, lighting should be between 300 and 500 lux for 60 to 100% of the time. Our ergonomics team at OHCOW had a discussion surrounding lighting, and the consensus was that the CSA standards were a better representation of the required illumination needed, which provided the most comfort for workers. So CSA has an illumination of 75 to 300 lux for computer work alone, while they suggest 200 to 500 lux for a combination of both computer and paperwork. So the reason for this is that having a contrast between the computer monitor and background lighting in the room is important for better visual feedback from the task at hand. So therefore, if you're using a computer only, the illumination factor can be less than that while reading off a piece of paper. So glare and unwanted dark spots or shadows are also important factors to consider. So excessive glares and shadows can cause more eye strain, can cause the visibility, or can reduce the visibility of the task, and therefore reduce comfort and productivity. And it can also cause awkward postures and headaches. So when looking at lighting controls, the goal is to reduce discomfort to the eyes. So how can we do that? Well, we can use indirect lighting by placing filters or diffuse overhead lights. We can dim the overhead lights. We can cover the windows with adjustable blinds to control the natural light coming in. Can ensure your visual tasks or the line of sight is parallel to the windows so that you're not getting that direct glare from the natural light. Using matte finishes on walls, floors, and furniture, just to eliminate glare or to reduce glare. Using task lighting when it's necessary, and having a proper workstation setup is also important. So in summary, overall indoor environment quality depends on 4 major factors in a building, all of which complement an ergonomic workstation. So you have temperature, acoustic environment, indoor air quality, and lighting. Ergonomics is about total worker comfort and the prevention of musculoskeletal injury. So therefore, if ever you find yourself in a situation where a worker or multiple workers are having a hard time being comfortable at work, remember to consider the indoor environment quality of the building when completing an office ergonomics assessment. These can be important factors, and they shouldn't be disregarded. So thanks for your time. If you have any questions, I'd be happy to answer them the best I can.
Okay, that's great. Thank you, Andre. You do have a few questions.
Okay.
The first one is, does tail align with LEED and/or the well building standard?
It was actually kind of based on that. But so tail comes from the European Union, so it's a little bit more stringent in terms of having more parameters to look at. So yeah, it does align with LEED and building standards and everything. So.
Okay. Any suggestions regarding perfume or scents?
Well, yes, I would say to put an administrative control in for that to limit the amount of perfume or any perfume for people to be wearing. The more you have scented candles or perfumes in an area, these can affect other people in the surrounding area. So if it's not just for you personally, then I would recommend putting in a policy to limit that type of product coming into the workplace.
Okay. I think you answered this one already, but is tail something that is supported by the ACGIH?
It's not it's not really a supported thing. It's kind of a complementary thing. So it's just an area where so it was a study that was done to bring all of these things, all these parameters together. And we've kind of used this as a good measure or we reviewed it as a measure for health in a building. So good indoor air quality or good indoor environment quality. Whereas, there's ACGIH standards that you can use as well, and they're very close to this. So if you feel more comfortable using that standard, you can. It's just a good measure to follow. It doesn't mean you have to follow it perfectly, right? You can use other standards that work very well. The thing that's nice about the tail criteria is that it was all kind of brought together in one place. So you have a table with recommendations to follow, and it's a relatively new study. Like this study was done in 2021 and it developed in 2021. So yeah, I think I'm sure if you use the criteria, it would align itself pretty good with ACGIH. But ACGIH is more occupational health related and not just air pollution related. So there's other standards for that as well. So
Okay. Any recommendations for white noise equipment installed in an open office environment to reduce distractions?
white noise to reduce distractions. Well, sometimes it can cause more distraction. So it all depends on, like in an open environment, there will be a little bit of noise that it's good in a way, but it's not in another. It depends on how close it is to certain people, and what the noise level is. So you'd have to measure that, if you're putting a fan or something in a corner and it's producing noise, well, it might be good for the person that's far in a farther cubicle, but might not be so good for the person sitting right next to it. So um, I don't know if I'd recommend to put a device to provide white noise. It could be good in terms of, providing privacy in a way, but sometimes not so good for comfort.
Okay. Next question is, why is there a low range for noise, less than 35 decibels? Does low noise levels affect the body?
It's more for comfort and like if it's higher than that, you start to lose, you start to have more discomfort and having productivity, uh, or lower productivity. So that's kind of where it doesn't harm your body in any way, for anything below 35 or above 35. The only time it really becomes an issue is, above 85 decibels, to reduce. So we want to get away from noise-induced hearing loss, obviously, but this is more an office setting. So it's more looking at distractions and like annoyances.
Okay. The next question is, do you need to add VOC parameters if the area is in the post-renovation state? If so, what parameters?
You don't really need to. You could just look at VOCs in general, because it'll kind of capture everything, and you'll know that it's probably off-gassing from the materials, and that would be like glues and different things. And formaldehyde could be part of that. Benzene's likely not, unless there's like fuel spills and things like that. Um, but in order to add those parameters, you'd have to calibrate your system to measure these specifically. But normally it measures like total VOCs, for a handheld device. Anyways, you can have other devices that are specific, but yeah, I wouldn't. If it's just a new building, I wouldn't really look at different parameters. I would just look at total VOCs, and if they're elevated, then you know that it's likely from the building materials, and then you can increase your ventilation based on that, for a few weeks until the off-gassing is done.
Okay. Next question is, how to best use the NIOSH app to measure noise in the office environment?
Well, the NIOSH app is actually pretty good. It's pretty accurate, but that you can do spot tests with that. Kind of use it as a sound level meter, but in an office environment, yeah, you could just measure different places where people think there might be distractions. If you're close to if you have a server room or something like that, you can measure the desk that is close to there and to see what kind of noise you're getting from that. Um, just finding different areas that might have higher noise levels in the office, that would be a good place to start. And then you can implement controls from there.
Okay, great. Next question was, I've kind of truncated it down, but uh, just moved to a new office. Although the central heating system says it's 21 degrees, we're having issues. The space is on ground level, carpeted floors, one large wall is completely windows. There's nothing on the walls, very high ceilings, and there's low cubicle walls. Would all these things also contribute to the office feeling colder?
It could. Well, 21 degrees is not hot. It's not warm. Most people at 21 degrees feel cold. And that's why we recommend 23 to 25 degrees. And this was also like, if you look at the table, like real world studies that OHCOW did. We had some hygienists go in and take temperature readings, and most people felt more comfortable at 23 to 25 degrees Celsius. Um, and anything lower than that, they felt cold. So maybe just increasing the temperature, of your system to 23 just to see how it feels. That'd be a good start. And if you're allowed to, I'm not sure, like most places can, but I know some people put a lock on their thermostat, but be something to look at.
Okay. Another question is, have any office buildings noticed an increase in reporting of gas smells during colder months?
Um, Not that I know of. It all depends on whether there's a garage underneath the building or not. I have heard that from places like buildings that have parking garages, where you might have some, uh, gas fumes coming in or like exhaust fumes coming into the building, um, then you might see that in the lobby area. But otherwise, if you have a good ventilation system, typically not.
Okay. Next question's regarding lighting. The first part is how is lux measured? And then the second part is any suggestions when purchasing a device to measure it?
Well, light meters. So they have devices that measure light and it gives you the amount of lux that it's producing. These are the devices that we recommend. You can get them fairly cheap. Yeah, a light meter would be good, and but you got to think when you do get these devices, they're supposed to be calibrated every year. So there's an extra expense there when it comes to purchasing equipment.
Are there any apps or anything that can measure light?
I don't think so. I'm not exactly sure on that. I'd have to look that up.
Okay. Okay. Any ways to measure and reduce echoes?
Well, to reduce echoes would be, having sound absorbent materials, because an echo like they're from hard surfaces, right? So if you have something loud and you have hard surfaces all around your house, like concrete or, um, you know, carpets are a good absorbent, but if you have a hardwood floor, it'll produce more of an echo. So, just having sound absorbent materials on your walls and ceilings, that'll really help reduce echoes.
Okay. Are there any common materials or strategies used to help control or dampen noise in general? For example, using waiting spaces.
Waiting spaces, what do you mean by
Yeah,
that?
I guess like a waiting room or a waiting area in an office
Okay.
environment.
Well, again, it would just be like sound absorbent materials, and then if you want to close off the space so that it's not in an open area, then it wouldn't be as distracting. So there's some places that that's what they do. They have a waiting space that's separate from the office space, so that you know, you're not getting the distraction from the waiting room, from people talking and things like that. And if it's a reception area, you can have the glass covering, and that also, gives a separation and noise barrier. Um, so things like that can be, you know, added to reduce the noise from the wait.
Okay, great. Andre, thank you very much.